Good evening, Bearcats. I hope that you found your graphing part of your test today not too terribly bad. We will have an opportunity to get some bonus points later this week, probably on Thursday. I will probably let you do a graphing page on Thursday for a few points added to your test. But on Friday, we will be writing equations given a graph or given actually information about a graph. And if you're given information, which is what really most of your test is like, you will sketch the graph and then you will write the equation from the graph. So those are the couple of things you're going to do. Okay, tonight we're going to work one where I give you a graph, and then we're going to work one where I give you information, and that'll get you started. You'll pick up the worksheet when you come in tomorrow, and these are actually 2 off of your worksheet. I believe it's number 1 and 5 off of your worksheet, so you'll have an example kind of to get started. All right, so let's take a look. We know that we're going to write the graph both as a sine function and a cosine function, and let's take a look at what we know. All right, if we take a look at this, the first thing we're going to identify is our axis, just kind of like we were doing on our graphing, our axis. If our y values are at 2 and at 1, 2 and that should be a -1, 2 and -1, then to find the axis, it would be halfway between that. So I'm going to do some little bit more than I would normally do, just since it's the first time we're working on this. So I would say that you have 2 plus -1, and then you want to divide that by 2. Well, 2 plus sorry, I paused for a minute because I'm a little tired. I wasn't thinking. Cross that out. I'm going to erase that. We're just going to erase that. Oops. Okay, let's erase that. Let's start over on this. So sorry. Okay, sorry. We would normally do that if you were given a max and a minimum, but we're not given a maximum. We're actually given a point on the axis, and I just was thinking that was the max. So our point on the axis is at 2, so therefore our axis, of course, would be y equals 2. And it'll be plus 2. It's positive at the end of your equation. So we know all of a sudden at the end of our equation we're going to have plus 2, and at the end of this equation we'll have plus 2, regardless if it's cosine or sine. The next thing we want to do is figure out our amplitude. Well, if this is 2 and this is at -1, that total distance is 3, because you would get to 0 and then you would add another one. So the total distance is 3. So this amplitude right here would also be 3. So our amplitude is 3. It appears in a sine graph, if you start right here, you go up first, so it would be positive 3. In a cosine graph, we would start right here, and it would start at the top of the amplitude, so it would also be a positive 3. So 3 would be our beginning regardless. Now, the next thing we're going to learn is that this is a sine graph, so we're going to write this as 3 sine, and we're going to write this one as 3 cosine. And then we got to worry about if there were any horizontal changes. The first thing let's do is see if we can identify the period. Remember, there are 4 parts to our graph. There's this curve, and then there's this curve, and then there's this curve, and there's this curve. So there's 4 parts. So if we know one of the parts, then we could multiply times 4 to find the entire period of our graph, or entire cycle of our graph. Well, from this point to this point would be 1/4 of our total cycle. So let's figure out what the difference of that is. So we would take 5 pi over 12, and we would subtract pi over 3. All right, I'm going to go ahead and do the math with you this time. I won't always do that, but I'm going to go ahead and start with the math. So if I do that, I would have 5 pi over 12 minus, and 12, this would be 4, 3 times 4 is 12, and 4 times 1 is 12, so 4 pi over 12, and that difference is pi over 12. So my difference is pi over 12. Now, that would be 1/4 of my graph. So if I multiply that times 4, which is important, if I multiply that times 4, I believe I get pi over 3. Pi over 3. So I would have 4 pi over 12, which would equal pi over 3. So it looks like to me that all right, so pi over 3, that would be our all the parts. Now in the equation, remember our original period was 2 pi. And remember the little formula to find period is 2 pi over whatever the b value is. All right, and that in this case should equal pi over 3. So let's see what we have to end up doing. We would end up, and that would be pi over 3 over 1. So we would have b times pi over 3 equals 2 pi. So we would divide by pi over 3 or multiply by 3 over pi. And when we do, the pi's would cancel out, and 2 times 3 is 6. So it would be 6, and this would also be 6 because the period would be the same. And now we're going to have x either plus or minus something, depending on our shift. All right, the next thing we want to do is for sine, we want to figure out what this point is because we want to know how far away from the origin it was. And for cosine, we're going to want to know what this sign is because this would be the beginning of our graph. Well, we have this point, and we know that each segment, each little part, is pi over 12. Pi over 12. So we're going to take pi over 3, and we're going to subtract pi over 12 from it. And that'll make us go backwards. So if we do that, we're going to change this to what? 4 pi over 12 minus pi over 12 would give us 3 pi over 12, which gives us pi over 4. So this point would be at pi over 4. So for cosine, we would have to shift to the right pi over 4, so we would say minus pi over 4. For sine, we have to go back another 12. We could either take pi over 4 and subtract a 12th, or we could have gone back to pi over 3 and subtracted a 6th, whichever is more comfortable with you. I'm going to just take my 4 since I'm here, and I'm going to subtract another pi over 12. I'm going to change my denominator. This would be 3 pi over 4, or 3 pi over 12, minus pi over 12, which would be 2 pi over 12, which is pi over 6. So pi over 6, this point would be at pi over 6. So from the origin, I would have to shift to the right to begin my graph at pi over 6, so minus pi over 6. And that's how we graph, or we write equations from a given graph. Little more tedious than graphing, but if you understand graphing really well, this won't be too bad. All right, so let's go take a look at one more example, and then we'll have your worksheet tomorrow in class. Okay, let's take a look at this example. This will be like number 5, or this is actually number 5 on your worksheet. So this is a cosine function, ends at the point, and I'm going to go ahead and fill this in for us, pi over 4, comma 6, and begins at the point, and we'll go ahead and write that in too, and that's going to be at pi over 12 and 6. And it's a cosine function. Remember, cosine starts at the top of the amplitude, or starts at the amplitude, ends at the amplitude. All right, so let's sketch a graph. I think that's our best thing to do. So we'll sketch just a basic cosine graph. Okay, and this says it ends at the point pi over 4, 6. I'm going to label. And it begins at the point pi over 12, 6. So we need a few more key points. We need our axis. We need a point at the bottom of the amplitude, and we need to know a little bit about maybe the points here. It also tells me we have a minimum value where y is 3. So this is some value, comma 3. All right, well, that'll help us find the axis, because if this is 6 and this is 3, then it would be halfway in between would be the axis. So for our axis, we would have 6 plus 3 divided by 2, which is 9 halves. And this is a cosine function, so we're going to say y equals, we'll have something, and eventually we'll have cosine, and we might have something more, but our axis is going to be at positive 9 halves, so I'm going to say plus 9 halves. The next thing we want to do is we want to figure out the amplitude. if this is at 9/2, which is 4.5, and this is at 3, then the difference would be 1.5 or 3/2. If this is 4.5 and this is 6, then the difference would be 1.5 or 3/2. So our amplitude is at 3/2. So that's going to go in the front. It looks like the graph starts at the top of the amplitude, so it should be a positive 3/2. All right, the next thing we want to look for is any shifts and the period. Now, the shifts looks like this would be pretty easy because we started right here at our graph, and this was pi over 12. So we had to go to the right, pi over 12. So we should be able to write our shift as y minus pi over 12. That's not too bad. So now let's take a look and see what our actual period is. The graph begins at pi over 12 and ends at pi over 4. So we need to know the difference between those two. That would be our period. So if we have pi over 4 is the bigger number, and we want to subtract pi over 12. Let's change the denominators to 12s. That would be 3 pi over 12 minus pi over 12, which would be 2 pi over 12, which is equal to pi over 6. So the period is pi over 6. To write our b value, it's our period of our original period of 2 pi, and we want to divide by pi over 6. That would be 2 pi times 6 over pi. Pi's would cancel. 2 times 6 is 12. And so 12 would be our b value to help us get to our period. All right. Hopefully this gets you started. You will have to do a little thinking tomorrow in class. You may help each other. I think you'll have 7 problems to work on, 3 with graphs and then 4 with information. I think the information, well, both are very important because you're going to have to sketch the graph on your you're going to be given information, you're going to have to write the equation and sketch the graph on this part of your test. All right, I hope you have a great night, and I'll see you tomorrow. Good night, Bearcats.